So in this lesson, we'll be looking at comparing fractions again. We'll be doing it in a different way because in the last section, we looked at numbers that had the same number in the denominator or the bottom. And we also compared fractions that had the same numerator or the same number on the top. So now what we're going to be doing is trying to compare when the numbers differ, when they're completely different. For example, 1/8 and 7/10. They don't share the same number in the bottom or the top, or the numerator and the denominator. So what we're going to do is take more of a look at like how we can do that using estimation. Okay, so here we're supplied with a variety of area models, and what we have to do is identify what the fraction is, and then this is the key piece. Okay, we're going to look at some benchmarks, and the benchmarks are going to be 0, 1/2, or 1. So after we put in the fraction, then we have to determine whether or not the fraction is closest to 0, closest to 1/2, or closest to 1. Obviously, if it's closest to 0, it will be very little shaded in. If it's close to 1, most of the area model would be shaded in, and if it's close to 1/2, around half would be shaded in. Okay, so let's look at the first one. So if we look at this one, we have 1, 2, 3 by 1, 2, 3. So 3 times 3 gives us 9. So we know the fraction's out of 9. And then if we count the shaded areas, we have 1, 2, 3, 4, 5, 6, 7, 8. So our fraction is 8/9. Okay, and that's closest to, if we look at this area, it's shaded in almost completely. So that would be closest to 1. Okay. Now, this next one we have 1, 2, 3 by 1, 2, 3, 4, 5. So that's going to be out of 15. There's 15 blocks in that piece. But there's only 2 that are shaded in. So our fraction is going to be 2/15, and that's going to be closest to 0 because it's not, obviously it's not full. Most of these are empty, and if it were to be closest to 1/2, you'd have to have at least a couple rows shaded in. Okay. Now on this one, we have 1, 2, 3 by 1, 2, 3, 4, 5, 6. So that's going to be out of 18. Okay, and if we count the shaded areas, we have 1, 2, 3 times 1, 2, 3, which is 3 times 3 is 9. Plus we have 1 more, which gives us 10. Okay, and if we look at this model again, I would say about half, maybe slightly more than half, but if we're going to say which one is closest to, that's going to be a half. Okay, down here we have 2 columns, and then 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 times 8 is 16. And then there's only 2 pieces that are shaded in, so that's 2/16. And that, you can see, is mostly empty, so that's closest to 0. Again, going over here to the other side, we have 1, 2, 3, 4, 5, 6, 7, 8. So our denominator is going to be 8 because there's 8 pieces total. And then our numerator is how many are shaded in. 1, 2, 3, 4, 5. So 5, and that is about halfway full. Okay, this one we can let's just look at these and see what we can tell really quickly. Okay, that's almost all empty, so it's going to be closest to 0. This one is nearly full, so it's going to be closest to 1. This one is, you can see, roughly halfway full, so that's going to be closest to a half. Okay, and now for the fraction pieces, 1, 2, 3, 1 by 1, 2, 3, 4. So 3 times 4 is 12, and there's only 1 shaded in, so that's 1. Now 1, 2, 3, 4, 5, 6. So that's 6 pieces in there, and 5 of them are shaded in. And then at the bottom here we have 1, 2, 3 by 1, 2, 3, 4, 5, 6. So that's 3 by 6. 3 times 6 is 18. And then if we count them up, 1, 2, 3, 4, 5, 6, 7, 8. So you can see how we can compare the area models, even though they don't have the same numerators or the same denominators, but we can look at using estimation skills to see which one is bigger. So this one is clearly bigger. You would get way more, your belly would be way fuller eating all these brownies than if you just ate 2 of these 15 brownies, okay? Okay, so on the previous slide, we had 8 area models, and we determined their fractions and decided whether, here are the fractions that we came up with, and decided whether or not they were closest to 0, 1, half, or 1. So now what we're going to do is we're going to take these fractions and put them in the appropriate section. We're going to sort of combine them all together. Okay, so if we look at the first one, 8 over 9, well, that was almost full, so that was closest to 1. 2/18, so only 2 were shaded in, 16 were empty, so this one was closest to 0. 10/18, that was slightly more than half, but not close to full, so we put that in, we classified that as closest to half. 2/16, again, was closest to 0. 5/8 was, 4/8 is exactly half, so 5/8 was just over, but it was closer to half than to full. 1/12, again, only 1 was shaded in, 11 were not, so that was closest to 0. 5/6, almost all of them were shaded in. And then 8/18 was just under half, so that was closest to half. Okay, so now that we've got those figured out, we can complete these 4 statements and kind of give us general rules, okay? So when the number in the numerator of a fraction, or the top, is close to the number in the denominator of the fraction. So like 7/8, 9/11, 15/18. So if we look up here, numbers that where the top is close to the bottom, those were always closest to the number 1. Okay? Now, when we have a number in the numerator or the top is very small compared to the number on the bottom, so 1 over 8 or 2 of 11, 3 of 18, that was over here where we have small numbers on top and big numbers on the bottom. That means that only a little bit are shaded in, so then the fraction is closest to 0. Okay, and when the numerator of the fraction is about half the size of the denominator, so 4/9 is just under half, 6/11 is just over, 14/30 is just under. So again, here, these were roughly in the middle. Not quite close to the number on the bottom, but definitely not 1s or 2s, okay? So then those are closest to the number half. Okay, and then this last rule here, when the numerator of the fraction is the same as the number, and that, so if you have, that's the key, if you have 3 over 3 or 8 over 8 or 11 over 11, then the fraction is equal to the number 1, okay? It's just saying that's exactly 1. Like if we had 11 pieces on the bottom and all 11 were shaded in, then you have a whole cake or a whole loaf of bread or whatever you want to call it. And then this summary right here, just a reminder, so 0, 1/2, and 1 are benchmark numbers, because most people understand that quality. You understand that 0 is almost empty, half is half full, and 1 is like a full cake or a full loaf. So comparing fractions on these benchmark numbers is useful when we try to understand the size of fractions. So we'll look at some examples of how to do that. So if we're given an example where it asks us to put the orders and fractions from smallest to largest, and they don't all have the same denominators or the same bottoms or the same tops, then what we can do is our closest to 0, half, or 1 in order to do that. So let's just do that for each of these fractions. So 15 to 16, that 15 is very close to 16, so that's closest to 1, okay? 3/7, 3 is, it's not super small and it's not super big, so that's going to be close to a half. 10 over 10 is exactly 1, so I'll just put a circle around that to say exactly 1. And then 1 over 32, Well, that means only 1 out of 32 are shaded, so that's closest to 0. So then if we're looking at which is the smallest, the 0 is the smallest, so I'm going to write 1 over 32 first, okay? Then the next smallest one is a half, so that's only a half pan, which was 3 over 7, so I put 3 over 7 here, okay? Then, now trying to pick between these two, they're both 1s, right? But this one, if you think about it, that's a brownie pan with 16 brownies cut out, and 15 of them are shaded in, so you're still missing 1, whereas this one's cut into 10 and all 10 are still there. So this one has slightly more. Even though this one's close to 1, this one is exactly 1. That's why I put the 0 around. So this one is smaller than 10 out of 10. So we're going to put 15 sixteenths over here, and then obviously the last one is 10 out of 10. Okay, so again, use your closest to give you a guide, and then when it comes down to it, if you have two to compare, look at, you know, which one is the absolute closest to the number on the bottom, which numerator or the top is closest to the denominator or the number on the bottom. Okay, again, we'll look at which one these are closest to, and that'll help us order these fractions. So this fraction here, 16 slices, but only 2 are there, so that's close to 0. 11 is very close to 12, so that's close to 1. 1/16 is very close to 0. 8 over 8 is 1 exactly, so I'll put a circle around that. And then 15 over 32, that's close to half. Okay, so now what we've got is we've got 2 zeros, so those are going to be the first two. We're just not sure which one goes first, right? But if we look back to our rules that we did in the previous lesson, these two have the same denominator. So now we can compare them fairly easily, because if you recall our rule, if numbers have the same denominator or the same bottom, then whatever number is bigger on top is the bigger fraction. So 2 is bigger than 1. So you can imagine that you have 2 brownie pans and they're both sliced into 16 pieces. Well, if this one has 2 pieces in it and this one only has 1, this one's obviously going to be the bigger one. Okay, so this one is bigger, so that means that 1/16 is the smallest, and we should put that one first. Okay, so 1/16, and then obviously 2/16 would go right after it. And then we're looking for, so we've crossed out that one, crossed out that one. Now we've got 1, exactly 1.5. Well, half is smaller than exactly 1 and smaller than close to 1. So 15 over 32 was close to half. And then 11/12, again, 8 over 8 means the entire brownie pan is there. There's all the brownies are in there. This one is almost full, except it's missing one small piece, but it's still not completely full. So this one's smaller than this one, so this one goes first. So we have 11/12, and then 8 over 8. So again, the key with this one is when you have two that are like both close to 0, you go back to your old rules and remember when you have the same denominator, the one with the larger number on top, or the larger numerator, is the larger fraction. Okay, again, so here we are. We're going to order the fractions. We're going to put their closest value to. So 8 over 9, 8 and 9 are very close together, so that's close to 1. 4 over 4, that's exactly 1, because the whole tin is there. 9 over 16 is about a half. 8 over 10 is close to 1. And then 3 over 32, that means that there's 32 slices, but only 3 are there. So that is close to 0. Okay, now, again, going back, our 0 is obviously going to be our smallest one. So we'll go back here and write 3 over 32, okay? So that one's done. Now we have 2 1s, two 1s and a full 1. But actually, the half is smaller than all 3 of these. So this one's going to be the next one, 9/16. Okay. Now we have two close to ones and a full one. Well, we know this one's going to be the largest. So it's between these two. And again, if you look at these two fractions, 8 over 10 and 8 over 9, they have the same numerator. And this is where going back to our rules. If you have the same number in top or the same numerator, then the one with the smaller number on the bottom is bigger. Because if you think about this one's cut into 9 pieces, and 8 of those 9 pieces are there. Whereas this one, you have 2 empty slots, because 2 unshaded ones, because you have 8 out of 10. So 8 out of 9 is bigger than 8 out of 10. So that means that 8 out of 10 will go here, and then 8 out of 9 will go there. So 8 out of 10, and then 8 out of 9. And then obviously our last one is 4 out of 4. So again, when you're trying to do these in your practice questions, what you want to do is pick out the closest value, use your estimation, which ones are they closest to, and then if it comes down to it and you have two numbers that are close to 1, then look at the numbers and see if you can use those other rules that we had, whether or not they had the same numerators or the same tops. And you could also use your other rules for having the same denominators or the same bottoms. If you have any questions, see your instructor.